Okay, so here's a little bit of extra help in case you missed the lesson in 2.5 in class or just you're reviewing for the test. I want to look over a couple of things. So 2.5 was about all the postulates um, and paragraph proofs. So we have 2.1, which is any 2 points make a line. 2.2, you need 3 points to make a plane. 2.3 is that if you have a line, you have at least 2 points on it. 2.4 is if you have a plane, you have at least 3 points on it, and the key is they're non-collinear. So a lot of people will miss that by not saying non-collinear. And then in 2.5, if 2 points line a plane, then the entire line also is in that plane. 2.6, if two lines intersect, they intersect in exactly 1 point. And 2.7, if two planes intersect, then their intersection is a line. So here are the problems that we had for homework to take a look at. So here we go. I'm going to go to the video. So number one is asking which postulate does this work with. So it says number one, it says P and Q, planes P and Q intersect in line R. That is any two planes intersect to form a line. Okay. Number two is lines R and N intersect at point D. That's any two lines intersect at a point. I know this is sloppy, but I'm just kind of doing this rough. In class, we'll be a little neater with it. Number three is line N contains points C, D, and E. A line contains at least 2 points. Okay. 4, plane P contains points A, F, and D. A plane contains at least 3 non-collinear points. I mean, they could be collinear, but at least 3 non-collinear. Number 5, line N lies in plane Q. That is, if 2 points lie in a plane, so does the line. Okay. And number 6, last one, is line R is the only line through points A and D, and that is 2 points determine a line. I'm sorry. Through any 2 points, there exists only one line. Okay. So I know that's super sloppy, but that does cover all of our postulates we talked about. Okay. Next example, we talked about in class, is this. Given that M is the midpoint of xy, write a paragraph proof to show that xm equals my. Okay, so here's xy. Here's m. Okay, so we got to write a paragraph proof for this to show that. So given this, given m is the midpoint of xy, it means that xm has to be, or sorry, let's not say it that way, that it means that m is the same distance from x as it is to y. Okay, I know it's super sloppy, but hopefully you can understand the words I'm saying. I'm just trying to write it quickly because it would take forever to do all this on video. Since that happens, since the distance from x to m, which is xm, and and m to y, which is my, is the same, by definition of congruent, xm is congruent to my. That's what we're trying to show. Okay. So again, I know this is terribly sloppy. I would normally type it up, but all the notation stuff's kind of in the way. And in class, I'll make it look prettier and neater. I made it hopefully look prettier and neater. But the key is, since M is the midpoint, okay, it means it's equidistant from X and Y, which means the length from XM is the same as the distance from YM or MY. And if it's the same distance, that means they have to have the same length, which means by this definition of congruent, they have the same congruence, which is what we're trying to state. Now this is really annoying because it should be a lot easier to say this, and it is. We have right here our first theorem of the year. And what a theorem is it's not a postulate, but it's like a postulate in the sense that it is a property we use, but I just proved that it's true. Whereas, and the other ones I'm kind of taking for granted it's true because of the way things work. So we'll never have to go through all of this mess again if it says M is the midpoint of X, Y to write a paragraph proof. I'll never have to do that again. What I can do now is just simply say, yeah, I know that XM, or the parts are congruent because it's the midpoint. Okay. And then the rest of this section is just kind of about writing these proofs out. So the last example I want to look at for this video, and we did more in class, but really this is enough for the video. Okay. All right, so we got that point L is the midpoint of JK, and JK intersects MK at K. Okay. So if MK is congruent to JL, prove that LK is congruent to MK. So that's what we're going to have to explain. Okay, so the first thing we need to do is really draw this out. So L is the midpoint of JK. So I'm going to draw a segment JK, and I'll put L in the middle. Okay, which also means that JL and LK are congruent because L is the midpoint of JK. Now JK intersects MK at K. And we know that MK, so it's got to meet something like this. And we know that MK is congruent to JL. So we're going to prove that LK is congruent to MK. Now hopefully, I drew this and hopefully that makes it obvious, but this is one of the harder ones to explain. And we've already covered some of these things, but we'll kind of clear it up in the next couple sections as well. So given that L is the midpoint of JK, JL is congruent to LK by the midpoint theorem. Okay. Next, okay. Since it is given that MK is congruent to JL, we also know, okay, and this is the part where the new math comes into play, LK has to be congruent to MK by the transitive property. That was one of our properties earlier on in section 2.4 we haven't talked about since then. But the transitive property says that if two things, in this case LK and MK, are congruent to the same thing, which in this case is JL, that didn't show up very well, did it? Let's do a different color. How about yellow? I bet yellow will show up really nice. Fluorescent yellow. Yeah. JL, since it's congruent to these two guys are congruent to these two, they must be congruent to each other. Okay. That was a long extra section, but it's a tough section. So again, if this didn't help much, or if you were absent, or if you were trying to review for the test and still didn't help much, come in and I will see what I can do to make things better. All right, thanks.